Well, good morning, everyone. This is Leonore Nanenmacher from CEATI International. Welcome to today's training webinar for our Distribution Line Asset Management Program. And I will be on the topic of chasing the Holy Grail, improve cost, reliability, and safety at the same time. We're certainly glad all of you were able to attend this webinar today. Just before we start, I just wanted to let you know that everyone on the webinar is currently muted to minimize any background noise during the presentation. I do encourage attendees to submit their questions through the webinar interface during the presentation. And then during the question period at the end, you'll also have the option of pressing *9 on your telephone to unmute yourself, or you'll also be able to use the software's raised hand function as well. And also for your information, a copy of the presentation slides was included as part of the calendar invitation and reminder that you received earlier this morning. So at this time, I'm just going to pass it over to today's presenter, Mr. Budwin Nations from Copperleaf. So over to you, Budwin.
Thank you, and good morning, everybody. It's a pleasure to be here on this sunny day, at least here in Vancouver. When we prepared this webinar a few weeks back, Leonore and I were going back and forth, and she wanted a catchy title, so I gave her one. Now, of course, the challenge is I'm going to have to live up to that catchy title, so hopefully we'll get there. A very quick agenda of what we're going to do today. I'm going to start with a quick intro so you know who you're listening to, and then we'll dive into the famous three elements, which really, as we'll see over time, are really more than three. We'll actually look at mostly 5 outcomes that we're trying to achieve and then draw some conclusions from there. So very quickly, who am I and where do I work? I work for a company called Copperleaf. We're based here in Vancouver. We primarily do decision analytics for asset-intensive organizations like yourselves. You see some of our customers on the right. And it primarily translates into making the big decisions within your organization, so big capital planning decisions, but actually a lot of the methodologies and the concepts can be applied across all decisions that are asset related within the organization, and that's what we're going to be talking about today. We're present worldwide, although of course, very strong presence in North America, which is our home market. And I'm Boudewijn. I'm Dutch. With a name like that, it's hard to escape. I'm in charge of marketing at Copperleaf, which really means that I spend a lot of my time in international bodies, working on the development of asset management. I do this for ISO, I do this for SIGRE, and I'm also the chair of the Institute of Asset Management here in Canada. So when we think of cost, reliability, and safety, very quickly we converge to the triangle, and somehow triangles seem to work. I guess it's this kind of beautiful, simple geometric form, and it allows us to conveniently put 3 elements in focus, which is, I guess, something that we can deal with in our daily life. And indeed, if you go into the literature, and if my mouse wants to follow, you'll find, very similar triangles when it comes to asset management. So always trying to balance cost, benefit, and risk, somehow finding a trade-off in between. But of course, triangles are used for all kind of good stuff, like, for instance, what should we eat? And indeed, how do you make fire? And indeed, often triangles represent danger. So there is a bit of danger indeed in kind of screwing up, I guess, when we're trying to come up with the balance between cost, reliability, and safety. But nevertheless, clearly triangles are something that we humans like. Actually, we like them so much that at Copperleaf, we put triangles within triangles. But at the end of the day, same thing. What we do as a company is try to help you predict what needs to happen, then optimize how you do it, and then eventually manage it as you're executing on it. So triangles clearly are key. Now, the challenge with triangles is you can only deal with 3 elements, and clearly everybody's starting to declare independence. If you look at what's happening right now is, first of all, my fire triangle is turned into a tetrahedron. My food triangle is turned into a plate with a little kind of side dish there, I guess. My danger signal has now become a square. And you might have seen the macro out of Europe, the macro diagram, which shows what the 5 drivers are to asset value, which is interesting because that particular diagram is something which actually comes quite close to what we look at internally in Copperleaf, and I wanted to use as kind of a starting point for why you would want to be kind of considering a move from a triangle to something slightly more elaborate. And that is, if you look at the key 5 outcomes that we're trying to achieve, generally speaking, within our organizations, these are, generally speaking, pretty close. You want a improved risk profile as an organization, and of course that translates into kind of more detailed risk targets, as we'll see in a second. You want to improve stewardship, of course, of your assets, but also possibly of the environment and kind of wider concepts around you. Improved regulatory outcomes, in the sense that most of us are one way or the other regulated, and you want to make sure you stay on the friendly side of that barrier. Financial performance, of course, and potentially service levels. So the way you look at these 5 big outcomes is they have to be somehow mutually exclusive, as in, I'm dealing with separate things and I'm all trying to improve at the same time, and they have to be exhaustive in the sense that, if I do all these 5 things, then I'm really good at asset management issue, which as to run your company. And that's really the foundation on which, therefore, we can have built then the next layer, which is to say, okay, well, if those are the outcomes that we're trying to achieve as an organization, what do I need to do to get there? Interestingly, my mouse seems to have a hard time following me. There you go. You really need to kind of work on these 4 key pillars primarily, and then there's a foundation that we'll come to in a second, and those pillars are, of course, risk management, obviously, then a way of actually evaluating what you should do to actually address those risks and in general to kind of generate value for your organization, then choose from all those possible things that you could do, small and big, and then, of course, deliver them well. And if that cycle kind of repeats itself over time and across the organization, then you'll get to the right outcomes. And of course, below that, typically what you want to do is you want to be efficient and effective at actually running these processes. So in other words, you want to make sure that you do it in the cheapest and the most efficient way. That all makes good sense. So let's break this thing down into its pieces and try to see what it actually means for us in an organization if we actually want to achieve these outcomes. And the first one, obviously, is risk. So if we think of risk, and the 2 targets there is to actually have improved visibility and mitigation of risks, and then maybe more importantly, in a way, manage the whole business to an agreed risk profile. Because of course you can never get to risk 0, or that would be extraordinarily expensive and presumably over the top. So really what you want to do is you want to actually manage to an agreed profile, something that we all within the organization feel comfortable with, and that maybe outside regulators or outside stakeholders can also live with. So to achieve that, I'm really looking at 4 elements that I need to put in place to actually be able to kind of get to that enhanced risk management. And that is, of course, I need the data on which I can build, because if I don't have data, I have nothing to reference myself against. I need a system of some kind, a framework in which I operate. I need to be able, because of risk, to predict how it will evolve over time, and then I need to be able to communicate that to the rest of the world. So breaking that again, looking at data first, in our case, in distribution land, because we often deal with very large populations of assets, think of poles or something of that nature, generally speaking, we have very scarce data, very limited data on our assets. Very often, actually, the thing we do have is age. As in, we know when the assets were installed, and that's about it. So we can build a histogram like we see here, but that's about as much as we can do with our data. Now, this is not necessarily bad. Age for many of our assets is presumably a good enough proxy to actually allow us to build a strategy on top of it with regards to when we have to intervene on them. You might actually, of course, want to break them out as much as you can into smaller populations. Here it's done by type of circuit breaker, but you could very much think of, even if you think of poles, you might have different geographies in which they react differently due to weather circumstances or whatever, urban versus rural, etc. So you can break them out as much as you can so that you can actually build strategies for every one of those smaller populations, and that might be a bit more effective. In an ideal world, of course, you'd want to have better data. In other words, you'd want to have condition data. And there are many different ways of getting to that. Those are improving too over time. But condition, generally speaking, is a better way to compute risk than age would be, just because it now relies on more granular data for the individual asset to actually tell you in which condition it is. If I then know how critical that particular asset is, I can compute risk, of course. So this is a step up, but of course it's expensive because you have to actually go and effectively monitor your assets. So there's a balance that has to be reached there. And speaking of balances, right now, of course, we're getting more and more into the world of the Internet of Things, where, as the catchwords go, you're essentially building a connected asset lifecycle management system, which infers that there is tons of data available. And when you say tons, automatically you wonder if that's not too much. In a way, when you think of it, asset management doesn't need much compared to operational environments. We actually live with relatively scarce data. That's good enough for us because most of our assets don't degrade that fast, and we can see it coming, and we can build our plans accordingly. So we don't take millisecond decisions, we take year-long decisions, generally speaking. So we're generally speaking secondary users when it comes to IoT and to the smart grid, etc. We're not really the drivers of such initiatives in most organizations, but we can certainly benefit of the data that actually results from such initiatives, and it can inform us in the way that we operate and in what we're trying to achieve. Now, we need a system to actually kind of understand what the data tell us. And the obvious system for risk is the risk matrix, in which if I have age or condition data or whatever type of data really, that will allow me to compute the probability of failure of an asset. Some correlation between condition and probability of failure, which we can get into. And then, of course, at the same time, if I know what the consequence of that failure might be, then I can actually determine, how risky that particular asset is. In many organizations, you'll wind up with something that looks very much like what we have on screen right now, which is kind of a 5x5 or a 4x4 matrix. And there'll be buckets in the sense there'll be some red area of the matrix, which is the area where you don't want to go, which you consider the risk to be unacceptable. Then a middle area, which is stuff that you should keep an eye on because they're trending towards the red, and then green, which is all good. The challenge that we see very often is that there's a strong kind of inclination to then give the axes numbers. So basically, the bottom left corner in consequence would be a score of 1, and the next one would be a score of 2, and 3, 4, 5, and the same on probability. And then you multiply the two to get a risk score. So in other words, the highest risk score would be 25, which would be 5 times 5 in the top right corner. The lowest would be 1 in the bottom left corner, 1 by 1. And that actually doesn't give me much of a proportionality, in the sense that what I'm really looking at now is a scale from 1 to 25. So in other words, if I'm somewhere in the middle here, I'll have a score of maybe 9 or 10 or something like that in that order. And then I have like 25 in the top here. So in other words, from the middle of the matrix to the top of the matrix, it's only roughly double, a bit more than double, but not much. And really in real life, that's not the way things go. The top right corner here should be absolutely catastrophic. It should be like an event which should never, ever, ever happen. Whereas the middle here is something which we can live with every day. So in other words, what we recommend, generally speaking, is to move on to something where you work on an absolute scale versus these kind of relative scales. And this absolute scale would go from 0, of course, in the left-hand bottom corner to some massive number on the right, maybe 10,000, say, for argument's sake. And if that's true on both scales, then you wind up with a super, super high number in the top right corner. In other words, the proportionality between no risk and massive risk is much higher. And this allows you to be much more effective in communicating that top right corner is something which you don't even want to dream of, because it's going to cost you billions or at least millions to fix it. So that's a key element, and then you can actually put the bar as to what is the maximum amount of units or even dollars, if you monetize it, that your company is comfortable with, and beyond that you don't even want to think of it. You don't go there. So you can still draw the the lines to actually say a low risk is somewhere between 0 and maybe 100, and then a kind of okay risk is from 100 to 1,000, etc. But you actually want to use scales which are much bigger or much more aggressive than 1, 2, 3, 4, 5. You want to actually often use logarithmic scales or exponential scales. So every time that you move up one step, you're actually moving an order of magnitude up. That's what we see as the most effective way of making sure that you really can express risk in a way that makes sense to the organization, both internally and externally. Now, there's different types of risk, and therefore, very quickly, the question will become, okay, well, how do I compare, when I say negligible for a safety risk, how does that compare to, say, an environmental risk or a CEATI loss? So in that case, we're into normalization. So what we strongly encourage organizations to do is to really kind of adopt a vocabulary that everybody understands and everybody agrees upon. So when I say negligible, it's the same thing that if you say negligible. And if I say major, more importantly, then we all agree on what major means. So this exercise of normalizing is actually quite important. And very often as a side effect, when you start normalizing your risks, or the consequences of your risks in this particular case, what you'll see is that part of the equation or part of the exercise will be trying to express what the financial loss might be at the different levels. So in other words, here when I'm saying that I'm incurring a major risk, what I'm really saying is that this could cost me between 5 and 10 million. Now, the interesting side effect of that is that it actually allows me to monetize the whole risk matrix. So in other words, now I can actually turn everything into dollars, and I can say that really what I'm trying to do is I'm trying to avoid to spend more than X. That would be an unacceptable risk for me. There is some resistance to this, in particular, of course, because it means that you might be putting a cost on a human life and other delicate subjects like that. But what I do see over the last few years a real trend towards monetizing everything, either in real money or in some internal currency, which within your organization everybody understands what it means. And the reason for that, of course, is because at the end of the day, if you're going to fight risk, so in other words, if you're going to try to mitigate existing risks, the only way to do that is to spend money. And at some point, you're going to say it's too much. I'm not going to spend more than that. So inherently, you're actually putting a price on your different risks anyway. But this is the core concept that basically is you need a matrix. The matrix should ideally be very aggressive in the sense of having logarithmic scales so that you can actually get to very high numbers so that it's an absolute number that you're looking at. And ideally, you want to monetize. And in doing so, often it's part of the normalization exercise that you would go through. So that's the system that I have in place to actually express risk and so that everybody understands risk and talks about risk in the same way within the organization. And that's key, of course. Once I have that, I can now move on and say, okay, well, that was risk today. Now, how will risk evolve over time? So my assets degrade. We all understand that, and we can describe that one way or the other. As the asset degrades, the likelihood of its failing increases, and consequently, the risk increases, which also means that somewhere in the future, likely, I'll have to do something about it. The question, of course, is when, which we'll come to in a second. So time is key in this concept because if I look at the evolution of the risk of my asset failing over time, as time goes on, I can see that the risk starts increasing. There might be some threshold at which I decide, this is the point at which risk becomes unacceptable to me as an organization. I'm going to spend money ahead of that moment to make sure that by the time I get to that particular moment, I'm done and I can actually reset the condition of my assets by intervening and therefore lowering the risk, and I start all over. And the avoided risk is the gray area under the curve here. So that's the way I would determine at which point I should intervene based on risk. And of course, if I were to delay the project, my risk would increase, and only then would I do the project. That's not good. So in other words, don't start planning to fix an asset at the moment that you get to the unacceptable risk. It's essentially too late. So you have to see it coming so that you can actually work towards it before it hits that point. And of course, if you are going to justify a project, don't justify it on the risk at the moment that you look at it, you have to justify it also based on the fact that the risk will continue evolving and growing over time as you're executing the project. So that makes it that much more urgent and compelling in a way. Now, how do I come to these predictions of what is risk going to look like, and therefore what's the degradation of my asset? Of course, very dependent on the amount of data that I have available. If I have good data, then I can build any number of models based on that, which will tell me exactly, based on history and based on other assets, how an asset is going to behave looking forward. Often we don't have data, or we have sketchy data, in which case we actually turn to the experts and we ask them questions, and that can be done, of course, in a totally informal way or in a very methodical way that you see on screen here, where we're actually going to start quantifying very specifically by kind of leading the witness, show me what you know about this particular asset and how it's likely to behave, and I will turn that into a set of rules, which in turn will kind of give me a mini model of sorts as to how this asset might evolve into the future. The future, of course, looks very different. It looks like this. Every time I go to a trade show, this is what I see. Some guy fighting with himself and with a digital twin. Now, in trade shows, this looks very funny, and somehow this is the only place where I see this happening. But there is something behind this, of course, right? Essentially, what we're trying to do there is we're trying to say, if we know the assets inside out, in the sense that we know their physical characteristics, we know the network characteristics, we know how the materials behave, etc., I can actually build from the ground up a digital twin, as in a model which will mimic the behavior of the assets from the ground up, and I can use that, of course, to model how the asset will most likely behave into the future. So it looks very futuristic, and frankly, every once in a while it becomes a bit too much. But there is practical applications. In our case, of course, especially in network modeling. So if you have a way of building a digital twin of your network, then you can also start computing, what levels of redundancy, what consequences of capacity changes, etc., will actually do to your network, and therefore validate if your risks are real, or if actually there is enough redundancy in the network that it doesn't really matter if one particular asset is risky because the consequences of its failure are not that high. And equally, we can start looking at the different interventions that we might be planning on our network and justify the real benefits of those interventions, knowing how the network would behave based on a number of different interventions that we might be planning at the same time. So predicting the effects of the particular existing assets and the interventions that we're going to do on those assets on a network, in a way, you could argue, is starting to look very much like a digital twin of your actual system, your physical system. And I do see more and more utilities are getting to the point where they do have a pretty good digital twin of their network. Now, that all tells you what to do. It still doesn't tell you when to do it, of course. And that's where economics come in, because at the end of the day, somebody's going to have to pay for all this. And when it comes to money, of course, time is of the essence, in the sense that there is a value to money which changes with time, hence interest rates and whatnot. So therefore, in economics, if you look at it, the base rule number one is the longer I can wait, the better I'm off, generally speaking, in the sense that today's dollar is more expensive than tomorrow's dollar as far as spending them. And this is what this diagram tries to express. If you look at it on the left side, we have the cost of actually intervening on an asset, and on the bottom we have time. And what I'm looking at here is the fact that the replacement, or in general the intervention cost, drops with time. So if I can delay working on a particular asset until next year or the year after, generally speaking, in today's dollars, that's going to be cheaper for me. So therefore, the motivation for me as a financial guy is to always say no, and to just push out stuff into the future. It'll be cheaper in the future. Now, the counter argument, of course, is that, as we know, that the risk of the asset failing increases with time. And there's a cost to that too. So over time, that cost will actually increase even in tomorrow's dollars, because the actual, like the diagram itself might be even steeper, and then if you kind of discount it for tomorrow's money, it drops a little bit, it gets a bit flatter. But nevertheless, there's a moment where it'll start really kind of run out of control in a way. If you add these two diagrams up and you add in your other costs, your operating and maintenance costs, ongoing operating and maintenance costs, you get to the total costs of actually running the asset. And there is a minimum somewhere. And that minimum is essentially what we call the economic end of life. So all things being equal, and assuming that you have the people to do it and that it all kind of falls into place, in an ideal world, in 2028 would be the right time to actually intervene on this particular asset, because that's the lowest total cost. So, you know, the blend of risk increasing, replacement cost reducing, and O&M floating around, the lowest point is here, and that's the point at which you should intervene. Note that that lowest point is not the crossing point of the curves. Some people confuse it and think that it's a crossing point of the curves. That's not correct. It's actually the lowest point of the addition of all the curves that you're looking for. So that's this point here. If you intervene earlier on that particular asset, what you're essentially doing is you're paying more to ensure higher reliability, potentially. And if you're delaying it, you're essentially gambling. You're hoping that your risk profile here will not hold true. In other words, the thing will not fail, and you can stretch its life a little bit. So, of course, this is all based, therefore, on good risk models, and of course also good cost models, so that your economic end of life actually is in the right spot. Now, the same logic could be applied to very large populations. When you think of poles, for instance, or something of that nature, wooden poles, you might have 1 million of those. Obviously, you're not going to do 1 million economic end-of-life calculations. There, what we tend to do is, again, we tend to take age or whatever, and we try to determine that, okay, well, on average, we should replace them all after 50 years. Which might give us a diagram a bit like this light blue here, where depending on when the poles were installed, you're going to have big lumps of that's not very practical. So generally speaking, what you'd like to do then is to smooth it out. So you're going to start kind of trying to push bits of the outliers here. Effectively, you're going to try to push them under the curve, whatever curve your level of work that you can do in any year, and it'll start looking a bit like so. Now, in addition, of course, to the light blue work, that's what you're planning, you're always going to have some reactive work, as in poles who will fail, either because trucks dive into it or just because you missed 1 or 2 poles that should have been replaced for age. So you're going to have some reactive work. And depending, of course, on the level of the program you put in place to proactively replace poles, the light blue, your reactive might be less or more important. So in other words, you could actually come up with different strategies for pole replacement, do nothing and just wait for them to fail, do a minimum, all the way to a very aggressive strategy. And of course, every one of them will have a different risk profile. Like the less you do, the higher your risk profile is going to be. But on the other hand, your costs might increase, at least at the proactive level, with the more aggressive plans. And somewhere in between is going to be a happy medium, which you're likely to adopt, especially when you consider that your money might be used elsewhere for other projects more usefully after a while. So that's effectively the rough equivalent of economic end of life for big populations. Once we have all that under our belts, we need to communicate all this to the rest of the world. And this is, of course, where pretty diagrams become very important. And back to the risk matrix, what you want to do, of course, is you want to populate it with your actual risks. Now, when I look at this company, I'm going to run for the hills, because pretty much all of their assets seem to be in the red or in the yellow. So there's something seriously wrong with this organization, or hopefully this is just a fictive organization and to prove a point here. But you can see that there's a massive amount of assets here in the red. So it's essentially already too late. Like, these things should have been worked on a while ago. But this, of course, is a very compelling picture. If you can put this in front of management and say, guys, this is the problem, then they get it pretty quickly. And in this particular case, I can actually go and zoom in and see actually what every single one of the little dots means. So informing the audience as to current state of affairs is important. So if you can move this thing over time, there's a little cursor in my case here on the right. I could move it over time and see how it evolves over time. That's even better, because now you can, of course, show what the likely evolution is under different strategies. You can rank them, of course, so you can start looking at, which are the worst behaviors or the highest risk assets in an organization. And if you're well structured, and we'll come to that at the very end of this discussion here today, you can actually also start looking at, do I have plans against those different assets? So in an ideal world, if I look at a list like this, I should have a project or some level of intervention already planned against all the top assets in this list, which essentially means that I'm in control of the situation here. Now it's a matter of justifying all this good stuff that you want to do. And when you look at most organizations, this is what you would typically face at the aggregate level. So when I say across the whole organization, generally speaking, what I'll see is, okay, well, this is a risk profile that I want to operate under, the black line at the very bottom there. In the next few years, I'm okay because I'm working on all kind of stuff right now. I know what I'm doing, but then the risk tends to creep up. And that's because as individuals, we're so busy doing stuff today, and the next few years, this diagram is now a few years out of date, that I actually don't have much time to plan for the long-term future. So there might be a couple of projects which I've put in there, but I don't really know much about the long-term future. So part of the exercise, therefore, is to actually using the models that we have now, simplistic or not, to actually try to determine at which point should I actually intervene on particular assets using the economic end of life gimmick, and then I can actually start kind of filling in these gaps with at least a number. It's like, look, I need roughly 50 million in 2016 and so many million in 2017 to actually keep the risk under control. So using the degradation models that we had, the economic end of life calculation, I can actually fill in the blanks here. This is just a wish list, of course. I'm not saying that we're going to necessarily do this, but I need to go and sell to management the fact that I need this kind of level of money in these years to actually keep risk under control. So this is a matter of justifying the future and preparing management for it. And another way of looking at that is to essentially explain to management, if you don't do it, this is what's going to happen. You can actually kind of spend less by effectively, saving money. So the blue line is how much am I saving if I don't do everything that I'm asking for right now. But the red line is the cost of the additional risk that you take on. And it's a matter of basically showing the inflection point. So there's a bit of an inflection point towards a 2/3 point here in this diagram where you say, look, beyond that, the risk is running away from the cost savings that I'm doing. So in other words, like saving more than this level of money is actually not very responsible, because the risk increase is now kind of going way faster than your cost savings. And of course, if you're more conservative, you might argue that already starts here, mid-size of the diagram, and that this should be your preferred spending level, and anything above that is too risky. So it's a matter of showing that if you don't intervene on your assets, your risk profile just gets worse and worse. And this is something which, both the regulator and the board might actually want to take into consideration, because it will come back and bite them. And then, of course, because we're in distribution land and our assets are all over the place, using GIS as a tool to actually communicate what we're really looking at is wonderful. So here I see, this is actually a gas mains as opposed to electrical, but the idea is very much the same, of course. What you see here is, all my green assets, which are, the little pipes which are in good condition, and then I have some yellows and some reds, and I can go and highlight every single one of the segments, the individual asset, and see what its risk profile is, what it would cost to replace it, et cetera, So you can really start informing the audience, both at the global level, just looking at in aggregate, what does this look like, and then in particular, how does it look for particular assets or particular neighborhoods, particular areas. So there's a level of visual impact which makes a hell of a difference when you're trying to convince the organization that this is the way to go. So with that, we have pretty much our risk understood, both today and moving forward. We have a way to communicate it. Now it's a matter of deciding what to do about it. And here, of course, the question becomes, we should do enough, but nothing beyond, which is the first sentence there. It's, reducing expenditures that do not deliver value. So there is a moment where you're essentially overdoing it. That actually doesn't deliver value to the organization. We should stop. And then there is this concept, which we'll talk a little bit about, the fact that it's not only about risk. There is actually the new bottom line in many organizations where you're trying to achieve many goals at the same time. So we have to understand those goals first. That's the corporate objectives. Again, build a system around how we do this, and on from there. So corporate objectives, any organization has them. They might look pretty like here, or they might look a bit more dry. It doesn't really matter. The fundamental idea here is that your corporate objectives have to translate into reality. So in other words, this concept of line of sight, which was used in PAS 55 for many years, where you have to have a way of translating what the big corporate objectives are into something that actually is actionable every day by individuals within the organization. And in doing so, you make sure that internal and external stakeholders all understand what the big picture is and how you can actually deliver on it. So to do that, we very quickly turn to this concept of value, which kind of popped up in the successor of PAS 55, namely ISO 55000. And the definition is, of course, that an asset only really exists to provide value. If it doesn't, you shouldn't keep the asset. And of course, it provides value both internally to the organization, but also to stakeholders, which might be external. It could be tangible and intangible, positive or negative. So negative value, you could argue, is where risk kicks in. And asset management as a discipline is really there to enable the realization of the value of the assets. So that's well understood. To go from risk to value, the way I always look at it is risk is essentially value destruction. If an asset fails, it's not performing its function anymore, I'm destroying value. So if I'm saying that over time, the risk of an asset is increasing, and at some point I decide to intervene, which would be here, and therefore I'm dropping my risk level much lower, and that is still all over, then the benefit is essentially the area in between the two curves, which is what I kind of added up here. And again, if you do the net present value of that over the future stream of benefits, then you come up with some number, which is essentially the benefits of doing the intervention on that particular asset. So to me, risk is just value destruction. That's the way, it's, for me, the simplest definition. And you want to avoid value destruction as much as you can. So in other words, you actually want to make sure that you have a good asset management plan in place for your existing assets. Now, the caveat is risk is not the only thing that you're trying to manage, of course. There's other reasons why you might want to invest in your assets for growth. You need to add assets. Well, there is no risk yet, but you're still wanting to spend money on it because you're going to extract value out of those assets. There might be a function change, modernization, etc. So there's very different reasons why you might want to actually invest money in your assets, which are not necessarily directly tied to risk. So now it's the matter of therefore defining what are the corporate objectives and how do they actually translate into stuff that you can measure, because of course you can only manage what you can measure. So I need metrics. So assuming that my organization's strategic objectives are here, like 5 big objectives, like safety, of course, the quality of delivery of the service, the brand of the company, the reputation, etc., important, environmental stewardship, and then of course financial targets. I'm going to actually break those down into lower or more tangible elements that I can actually measure, so that actually for every project I can actually pick out of this list whatever the elements are that are applicable to a particular project, quantify them, add them up, and that will be the overall value that that particular project brings to the organization. So now I can actually measure what I'm promising, and in retrospect, of course, also measure what I actually did deliver compared to what I had promised. And risk, of course, falls in there too. You'll actually see that there's a fair number of things which are labeled as risk: environmental, brand, health and safety, etc. So risk are very much part of the strategic objectives in the sense of the management of risk to acceptable levels, as we said earlier. Now it's a matter, of course, of making sure, very much like we did with risk, that we align all this stuff. So once I've identified the criteria of what I'm trying to maximizes value, I need to align them. So I need to make sure that I understand if we're talking about like one value, one element of reputation or one unit of reputation gained, how does that compare to 1 unit of risk avoided, safety risk avoided or whatever. So the same exercise we went through is the big matrix on risk. You could argue you have to do for all the value elements within your organization, again, recognizing the fact that time is of the essence in the sense that everything will change with time. Then I'm in a position to assess any intervention that I plan on my assets, give it a value, and then from that value, I can eventually decide which ones I'm going to pick, and we'll come back to that. One challenge that we see more and more is the soft stuff. So, when it comes to assessing a risk on an asset, an existing asset, that's relatively easy. But more and more organizations are trying to go for their triple bottom line or corporate social responsibility framework, which at the limit could translate into trying to achieve some of the sustainable development goals or contribute to them. So it's getting softer and softer, and assessing the benefits that are attached to that is not necessarily trivial. There is some elements that you can use. There is the famous concept of the willingness to pay. So in other words, are you customer willing to pay for us organization to actually contribute to a better environment? We can bury lines or we can do whatever you need to do to build a better environment, but there's a cost to that. How much are you willing to pay? You can actually ask those questions, and I've heard some interesting examples of people doing that and coming up with some pretty interesting answers actually. You can do the typical more kind of statistical exercises where you would actually start comparing things. So in other words, if I give you one element of this, how much would you are you willing to compare that to another element? So in other words, again, if I want to compare reputation to safety, can I actually come to a conclusion as to how many safety units are compared to one reputation unit or equivalent? So there's many techniques for that, but fundamentally the idea is that you have to be able to quantify in same value units, dollars or internal units, all the different strategic goals that you have in an organization and the metrics that are underlying them. If you have that under your belt, you can actually start showing what the value of any planned intervention is, be it a replacement of an asset, a refurb, or just a minor intervention. So in this particular case, like I have a transformer, and what I'm showing is essentially all the different benefits that I will extract from actually doing something to this transformer, intervening on this transformer. I'm reducing the safety risk, I'm reducing the environmental risk, I'm gaining some financial benefits, etc. And the way I like to show that is what we call the Pac-Man, where you're essentially showing on the inner circle here the relative proportion of the different benefits, including the negative benefits, which is the cost, which is the purple part here. And the outside mouth of the Pac-Man here, essentially what it shows you is the proportion of benefit versus cost. So in other words, inherently it shows you the cost-benefit ratio of this particular way of solving this particular problem that I had with this transformer. Now there's generally speaking more than one way of solving a problem. So you might have multiple Pac-Man for a particular project, or you can actually start looking at this over time because, of course, value and risk change over time. So you can actually look, in this case, at my 3 different ways of solving the problem, my 3 different options, and the way the value of those 3 options evolves over time. And, I can kind of therefore decide that if I have the resources, then clearly the blue is the most interesting one of the 3. That's the aggressive replacement plan that I had earlier for my poles. So I can actually look at that and go like, yeah, that's the highest net value, cost being already deducted. So I should do that. But of course, if I don't have the money, I might actually have to pick for one of the other options. And I can also see what it costs me to actually delay this program. So these are visual representations always of what you're doing, so that the organization at large actually understands what you're trying to achieve and how it would play out. Once I've understood how I can justify or show and justify every single intervention that I want to do, now it's a matter of deciding, okay, which ones should I actually do? Starting from the assumption that you're constrained, and you cannot do everything that you'd like to do as an organization. So it's a matter of generating higher value. Portfolios could be investments, could be smaller projects. And in the same way, of course, you might be very constrained by what the regulator tells you to do. And you want to make sure that actually is well taken into consideration. So if we look at the different elements that we need there, first, of course, the fact that we are constrained. And we're actually, generally speaking, very constrained. So it's not only a matter of money, it's also a matter, of course, of the resources that are available to me, human resources, equipment, etc. We might have operational constraints, as in, you cannot turn off the whole grid in one day. There's bits and pieces maybe that you can do only at some time. There might be timing, which could be climatic or otherwise. You can only intervene at certain seasons. There might be regulatory constraints. You must do things, particular things, which are regulated to you. And there is, of course, some constraints which at the same time you could argue are objectives. For instance, risk. I will not go above a particular risk level. You could argue that that's a constraint. You could equally see that as being an objective of the organization. Same with levels of service. You will not drop below a particular level of service. So there's different elements there that we can kind of put into this mix. The challenge being that the mix gets more and more complex, and therefore this grinder that we need in between there to come up with decisions actually has to take into consideration all these different elements. Note also that some of them, resources, a good example, might actually have both a maximum and a minimum constraint. You will not use more than 110% of your existing resources, but you will not drop under 70 either, because that would mean that a lot of people will be idle in the organization, which would be suboptimal. So we need a system for that, and what we mostly use in our organizations is good old spreadsheets. Of course, we rank projects based on their value, and then we look at some constraints, money being the obvious one, and we say, okay, well, we just add up the cost of all the projects that have the highest value, and we put a cut line somewhere where all the money has been spent or has been accounted for, and sorry guys, every project that is under the line will be for next year. So that's kind of okay, but it's not grand as a way of looking at it, and there's therefore more interesting things that can be done. And in particular, if you look at multiple constraints, so if you're trying to not only do the right thing from a cost point of view, but also from a resource point of view, from a risk tolerance point of view, possibly level of service, you wind up with essentially what is a multi-criteria decision analysis problem from a mathematical point of view, and that calls for different ways of solving, obviously more complex ways of solving, which really are all about trying to make sure that you're honoring all the constraints at the same time and still solve the same problem, the one that you're trying to solve in your spreadsheet, to the optimum. And the most common technique for that is linear programming, in which you're essentially expressing in mathematical equations the different constraints that you have, which actually graphically would look like surfaces on this diagram here. You see the different color surfaces, which are the different constraints. So you're essentially boxing yourself in as more and more of these surfaces are put in place, and you're somewhat trying to solve to find the furthest point from the origin, which would be the highest value, which in this case would be number 3 here. So that would be like the way to find the highest possible value within all the constraints that you had put in place. This, of course, needs a bit of computing power, but it's certainly totally feasible, and more organizations are going there. Now, this tells you what to do when under multiple constraints. So there's both the what, there is the when, which is timing, because it can tell you what you don't do today, I can do it tomorrow, and still kind of get a lot of value out of it, and you can have multiple constraints. There's a counter argument, which is to say, well, that's great, but there's also a matter of efficiency, especially for us in distribution. You might have assets which are co-located in the same neighborhood. It makes no sense to go back every 3 months and start all over, digging up the street or whatever. So there you might actually want to actually kick in with bundling algorithms, which actually look at where the assets are and actually start trying to bundle work by areas or by asset systems to effectively kind of increase the efficiency of the system accordingly. And you can actually start kind of looking at what different bundles would bring you as far as value. Now, you know, the key question that we get very often is, this is all great and it makes perfect sense, but it's work. How do I actually get people to do it in my company? So what's the incentive, in other words? And in particular, the fact that you know, our historic tendency as managers is, you know, what I want to find is, I find in the nicest possible way, I want to find a way to game the system. I want to make sure that I win. So whatever the rules are within the organization to actually get funding for my projects, the natural tendency would be, because we're all smart engineers, is we're going to try to find a way to beat the system and actually get our money, never mind what goes on elsewhere in the organization. And you need to get away from that. You need to get to the point where everybody kind of sees this as a useful exercise. And one of the ways that some people have found is internal competitions, in which what they do is they say, okay, guys, here are your budgets for all your different groups. These budgets were based on whatever historic data that you have on your risk profiles, everything well. But then on top of that, or as part of the exercise, some small percentage of your budget is now going to be put in competition with your peers, and the best will win. So we want to see business cases that follow all the rules that we just expressed. You know, they have to be computed on full value, et cetera, et cetera. And those will be put in competition, and the money will be essentially kind of stolen from one department and given to the other if they have better business cases that follow the rules. So in other words, you're trying to enforce the rules by giving an incentive that you can actually get extra budget if you play by the rules within the organization. And this is at a small scale. You could look at the same thing and expand it across the whole organization. And that's something that we're starting to see more and more now, is organizations where you say, like, well, once that principle is well understood, that is that, you know, the best should win, as in the highest value intervention should win, then I could play that across the whole organization, which is something that the CFO would love, of course. He would love to get to the point where we can actually make sure that we're extracting the highest possible value out of the money and the resources that we're putting in place by actually distributing all the funding and the resources in the most efficient way across the whole organization. Now, that can be very disruptive because you might need to correct, you know, mistakes of the past, and that can take time. So therefore, it might actually take a few years to get there, but we're starting to see very good examples of this happening as a second stage after the first little games, where you just put like small competitions in place between different departments. And the next stage, logically, is to make it into a big competition, if you wish. Communicating this, again, is key. So as we said earlier, and GIS is something which will come to the rescue in a big way here. We can really start showing what would happen under different investments levels. So, you know, this would be a small GIS project, which would give me a value per bundle of so much. If I do a different intervention, then I can see the cost is different, but the value per bundle is actually higher. So actually, this is a better intervention that I should therefore put forward. In the same way, management likes to be able to drill down into where is my money going. So the ability to have dashboards, which allows them to actually kind of go and drill down and try to figure out which projects exactly are we doing where, so they have a good view and therefore build some confidence on the fact that what we're proposing as a plan for this year, next year, the years after actually holds water, is very important. In particular, the fact that we can show the different scenarios and how they play out. So this is actually quite an interesting little diagram I found, where what you're looking at is the evolution of safety risk over time under different scenarios. You know, if you start cutting into the CapEx, if you're reducing CapEx, obviously the risk will grow for quite a while before you start catching up. If you look at the capacity risk, delivery capacity risk in the network, if you look at compliance, and if you look at the cost. So you can look at the different elements and see how costs, if you save in the early years, you're going to have to spend more in the later years to catch up, etc. So you can see different scenarios and kind of put these scenarios forward to management and say, okay, well, these are different ways that we could go about it. I will now leave it to your wisdom to decide which ones we want to undertake. what you're really doing from a technical point of view in showing these different scenarios is you're actually trying to show them that you've done your homework and you've come up with these green scenarios of, blends of projects that you'd like to do in the year to come, and that they are as close as possible to what's called in math the efficient frontier, which is really the best you can do with your money for the expected return. So basically, if this is the value that you're trying to create, there's some maximum that you can achieve. Like there's no way of creating more value than that with the amount of money that you're spending. The question is, where is it? That's what you have to find through the due diligence that we just went through, and then showing the different options that you have available, and also showing therefore maybe that spending for this green scenario here really doesn't give you much more value than spending here. So basically this is maybe the optimal that I would go for, because here you're marginally gaining a little bit more because the curve starts kind of flattening out. So this is presumably my most desirable package of work that I would like to do for next year. So communicating all this is key. Assuming you get approval for everything you'd like to do as an organization, then it's a matter of actually pulling it off. So you have to deliver. For that, again, what we're trying to do is to essentially reduce as much as possible any rework, and actually key is to really improve the delivery efficiency. Very often what we see in organizations is they have a lot of appetite for projects, but they actually cannot pull them off. So even if they get funded, they don't pull them off because all kind of stuff stands in the way, including lack of resources, etc. And then there's an intriguing second aspect to this, which I'll come to in a second, which is that you can actually start kind of doing some interesting work in your supply chain once you get this under control. So here again, data is key. Of course, here, if I'm going to try to manage what is being executed, very often it's out of my hands, in the sense that me as the asset manager, I've determined where my risks were, I've determined what I'd like to do, I've managed to justify all that, I've put it forward to management, they've agreed, they've approved it, and now I'm farming it out. Either to internal delivery teams or even to contractors, and I kind of lose control over the whole equation. And that's where things get a bit scary, and that's also therefore where I need to have very good systems in place to actually get back from those different teams information as to what's actually going on. So hence the term real time, which of course is to be taken with a grain of salt, because I don't need information every second of what's going on, but I do want to know on a quite high frequency what's going on. Are the costs in line with what we had predicted? Am I using the resources that I expected to use? Am I achieving the milestones that I put in place? And very often this means that you wind up building a bit of an ecosystem within your organization from an IT point of view, where you're sitting here, you've made your decisions, and you had used information from other systems to make those decisions, but in a way you were doing that at a very low frequency. Now you want information back from the financial system, from the work management system, possibly from project management. You want this back on a quite regular basis so that you can aggregate all that information back on your desk, and you can actually determine, I'm good, things are happening the way I expected them to happen. And if not, what do I do about them, of course? So one key element in that regard within our world and distribution is what we call achievements, because what we will do is we'll put for a block of work. We'll say, okay, I want you guys to replace 300 poles every month for the next year. And that's something that I predicted, at the beginning of the year, or maybe even before, and then the year starts folding out and things start happening, and possibly not exactly according to plan. And now it's a matter of how can I measure that? And one tool that some people use is this essentially achievements calculator here, where what you're showing is in different years, bottom corner you see the little legend here, 2014, 2015, 2016 plan. So every year you had like a plan of what you would like to do in a particular time frame, and then the red line is actually the actual. So now in this particular diagram we're in 2015, so we're a bit behind in time. The red is what we actually achieved, And under red were obviously the green and the orange, which seem to track each other quite well, whereas the blue line was off. So in other words, in 2014, we had predicted we would do this. And then in subsequent years, we've improved on our prediction of what would need to happen. And actually, reality seems to be tracking it quite well. But then if you look at, this is the aggregate of all the work that we're doing. But if you now start looking into polls, for instance, you can see that the story is a bit different. You can see that from year to year, we've been changing our prediction quite a bit, and we're still kind of tracking actually quite well to what we said in the latest iteration of the plan that we submitted. We're still kind of roughly on target, but we could equally start kind of diverging, and at that point we might actually want to replan what we would want to do in the year to come. So this is achievements in volumes of work or in units done in this particular case. You could also do it in dollars spent per unit, etc. And you can start seeing if you're diverging one way or the other. Another element which is very key, and it's used a lot in the UK in particular right now, is something called outcomes. In other words, it's all very well to spend the money and to use the resources, but who cares? What you really care about is, are you achieving the benefits that you promised as an organization? So in other words, what the regulator is going to look at is not that you spend your money. He's going to look at, are you achieving the benefits, the reliability, the customer satisfaction, whatever you signed up for. So at the same time that you're actually executing your projects, in an ideal world, you would also want to track, am I actually delivering on the benefits, on the outcomes that I had promised? This is tricky. This is sometimes very tricky, and it requires good data management in order to make sure that you can actually come up with those answers when the questions come. So as a system, therefore, at the minimum, through integration with your financial systems, etc., you should be in a position to actually do some level of variance analysis. So, in this diagram, what you're seeing is the spend for a particular project that had been planned, and then the actual spend, which is the red line, versus the blue, which was the budget. So you can see that in some months I'm overspending, in some months I'm underspending. On average, I seem to be doing okay. I might need to reforecast at some point at what the future will look like based on my current spend, etc. So this is an exercise which is ongoing in a way, in the sense that maybe on a quarterly basis, you should be looking at all your projects and say, how am I doing? Do I need to actually adjust? Because of course, behind all this, in most organizations, you have some level of cost control. And if you're going over, you're going to have to go for a reapproval of your budgets. And another way of looking at this, or maybe as a kind of summary of all that, is the fact that therefore what you're really aiming for is what I call here project forecast accuracy. So in other words, I want to make sure that every time that I forecasted a project, my costs, my resource needs, etc., I want to make sure that I was spot on. So this organization is doing pretty well, because if you look at this diagram, the vast majority of the projects are coming in, between minus to plus 5% of what was originally forecasted. So that's good. There's a few outliers though. Here there's one which is 50% over cost, but it's an emergency. This thing failed, so presumably they had to spend like crazy just to fix it, and it wasn't really planned in the first place. So these things can happen, but the idea here, of course, is you want to make sure that this column is as high as possible, and that's important. Just internally in its own right, but also because if you're good at forecasting what you're actually going to be spending on projects and what the timing is, you're essentially reducing the uncertainty both internally but also to the outside world. And interestingly, what we're starting to see there is if you become better at forecasting internally how you're going to operate, you can also start negotiating better terms with your suppliers, because they now actually know that you're actually going to be a reliable customer, if you wish, and consequently they can extend you better terms because there will be no surprises on their side. And this is where the real fun starts. What we're starting to see now is some organizations which really are good at collecting data, not only of asset data in the sense of risk and condition, or generally speaking, let's say the physical assets data. They're also good at capturing the cost of the asset, of course, the acquisition cost, but also intervention costs. So in other words, every time that a project happens on a particular project or on a particular asset. So anytime that we intervene on an asset in that organization, they're capturing the actual costs. So not only the projected, but the actual costs of that intervention. And that gives me the ability to, at some point, start modeling what did it cost me to actually intervene on a particular asset in a particular situation. So, what does it cost me to physically actually replace a pole? And of course, you have data all over the map, the little blue dots there, but you can now start kind of building a model out of all that actual data. So this is actual costing for particular projects. In this case, again, it's pipes, as you can see. So it's depending on the length of the pipe that you're replacing, you'll have different costs. But I can start kind of building a model between, like, well, for a particular pipe type, let's say, cast iron pipes. I know that a 20-meter cast iron pipe typically will going to cost me somewhere around $10,000. So I can build models, and these models I can now use every time that I need to do something on an asset. So my asset risk model is going to tell me that at some point I have to intervene on this particular asset. That can generate a project, as in a request for a project. That request for a project can then trigger a cost estimate generator. So in other words, I will actually automatically cost the project, if you wish, which will be fed into the project generator, which then can actually kind of come up with a list of projects which I need to get approved. So amazingly, we're getting to the point now where quite a few organizations, especially in distribution organizations, do all this completely automatically. So the only manual part of this is actually to execute the project, and of course, to get some level of approval. Somebody has to, at some point, approve it, but everything else happens automatically. So in other words, as long as I capture the costs in detail at the level of every project, and I have good data on my assets and good degradation models and good risk models, then I can automatically decide quote unquote. So in other words, come up with suggestions as to which projects need to happen. I can automatically cost them, and I can actually kind of put them in a hopper so that at some point they'll get approved through whatever mechanism is available within the organization. So this is pushing the envelope, of course. I realize that many organizations are not there yet. It takes a lot of data and quite a few years of history to actually pull this off. But you can imagine that once you're there, the efficiencies within the organization of actually kind of managing the flow of ongoing work that you always have to keep your assets in good state of good repair is quite remarkable. Another way of looking at this is, since we're looking at work underway, we're going to have to communicate where are we, what do we want to do. So in other words, you need a war room, maybe slightly less formal than this one, but fundamentally what you're trying to do is, very often, you will see it actually in organizations, we literally throw up on the screen, what are all the projects that are underway, what's the variance compared to what we originally planned, how do we need to react accordingly? So we start playing with what if scenarios, like what if we put more money on this project, on that project, how would the world look under those situations? So that's starting to happen more and more. And the other way that you can look at this is through the post-mortem lens, which is very important for many of us because we're regulated organizations. You actually have to justify post-mortem what happened. So you need a good audit trail, and you need to be able, again, to justify your outcomes, as I was describing earlier. And in that context, what's useful is to have a little dashboard like this, where you can actually see in a waterfall scenario what had originally been planned, which is the blue, and then stuff that was canceled, stuff that was delayed, stuff that came in below forecast, stuff that actually cost more, that was accelerated, that was new to the project, and therefore where you wind up. So basically, you wind up with these kind of scenarios which show you this on the cost side. It can also show you on the value side, and you can start comparing different ways of skinning the cat looking forward, or justifying what you did looking backwards. So again, very important to have your dashboard so that everybody understands exactly what we're doing and which projects are in play, which I see at the bottom here. And then finally, as if you remember from my original diagram, if we have all these 4 key pillars in place, there's a foundation, which is really kind of, you have to do this efficiently and reduce the time and effort that you put into it. One key element there is obviously to have a single source of the truth for all your data. We talked a lot about data and different elements as we went through this journey. clearly, you cannot have conflicting data. That's one of the biggest issues that we find in many organizations. So building a system in which there's one source of the truth for both the data, the models, etc. This is key. It calls for often integration between some of your systems. It could be a pretty informal integration in the sense of just transferring files every once in a while, but you want to avoid as much as possible any conflicts there with regards to your data. You have the issue of governance in the sense that you have to really kind of start tightening up your processes in such a way that you can actually justify everything that you are going to do or that you did, as we mentioned just a couple of minutes ago. Bandwidth is an interesting one. When you start kind of coming up with much tighter processes by which you both justify your decisions and make your decisions, generally speaking, it also means that management is much more confident in what's going on and actually can reduce the bandwidth that it actually applies to essentially kind of overseeing and getting involved in these pretty minute processes. And that, of course, has an unbelievable leverage because management time is expensive, even more so than our time. So reduced bandwidth as far as the bandwidth you have to apply to the system if you get this all in order is actually quite key. And then finally, one which I like a lot too is the agility aspect. If you looked at it, if you have your systems well in place, and they don't have to be complex systems, but if you have your processes and your systems well lined up, you should be able to kind of come up with different answers, different options to kind of possible ways forward as far as which projects to undertake under various conditions, etc., which actually give you the ability to kind of play with more scenarios, play with more options, essentially be more agile, come up with better answers to the organization as a whole. So back to where we came from, we started off with looking at the 5 key outcomes that we're trying to achieve. We looked therefore at the individual columns and how we could possibly kind of put in place elements for every one of those columns. Of course, in every one of them, we can go crazy in the sense that there is new technology and new thinking, which we can really push us to the limit, but we can start small and actually kind of put the processes in place at least to start doing the right things in every one of the columns. And then as you become better, the foundation there, of course, is kind of helping you along in the sense that, you can start putting physical systems in place now to help you and just become better and better at this game. So as a conclusion, first of all, clearly triangles are not going to cut it anymore. At the very least, we have to go to pentagons. We need to chase 5 things as opposed to 3. And I'm sure in the future we'll find more. This all is very much tied into what ISO 55000 kind of puts down as the key elements that we should be aiming for. So obviously value as the common denominator, assets are there to generate value. And therefore, we as asset managers are there to basically realize that value. We have to understand within the organization what our objectives are. That's the alignment, which translates then into value. Clearly, this is not going to happen overnight and without help. So leadership needs to really drive this journey to actually improve our processes within the organization. And ISO, because it's a plan, do, check, act system, insists heavily on the fact that whatever you put in place, there has to be a level of assurance. So in other words, whatever you do, you have to be able to do it repeatably, consistently, defensively, etc. And this is very true, I think, and we saw elements of this as we went around. Part of it is just the communication, the ability to communicate what you're doing on all the 4 pillars and actually show that you have a process in place, the results are there. That is a big part of it. The fact that you need to build an audit trail so you can actually post-mortem justify the decisions you made, etc., is often very key too. Clearly, it's something that doesn't happen overnight. You have to work on all 5 fronts, like the 4 columns that we talked about and the foundation around it. But I do think it's a journey which is worth it. And actually, most of you, I'm sure, are on their way anyway, one way or the other, on the different elements that we discussed. And then to finish off, if you want to continue this debate or if you want to read more, obviously, you can always contact me at Copperleaf. We have a number of white papers on our sites which kind of delve into some more detail on some of these elements. Another 2 key sources of information. ISO 55000 is publishing more and more complementary information around the standard itself, and you'll find that on the site that is mentioned here. And of course, the Institute of Asset Management, as you well know, has published quite extensively on how-to guides to actually implement a lot of the concepts of asset management. And with that, I am going to turn it over to you for questions. And I see that quite a few came in.
Good, and this is Leonor from CEATI. Just a quick reminder that I would just encourage everyone to kind of provide their questions through the webinar interface, and then also you do have the option of raising your hand on the webinar interface. So I could just unmute you so you can provide your question through the line, and then if you're on the phone, you can press *9 to unmute yourself. And I think we did receive a question from Parikshit via email. So it's a question about a slide that was just right at the beginning of your presentation, but when right before the risk matrix slide, and she would like to know what is the picture of the worker and the hard hat using a device on the wood pole, and she's kind of curious about what the device is doing and if it's some sort of inspection, perhaps.
Yes, it is, and I'm gonna say that, you know, as we most do right now, we shamelessly steal stuff off the web. So this actually is a device from EA Technologies out of the UK, and I'm going to profess total incompetence as to exactly how it works, but clearly it's measuring some degree of something in the wood. I assume humidity or something of that nature, but I might be totally wrong. So the image comes off EA Technologies. If we're going to go into specific inspection technologies, that's presumably another day's worth, and you'll have to find another speaker because I have a very sketchy knowledge on that. I'm a mechanical engineer. I know nothing about electricity, I'm afraid to say.
Thank you. Is there any other question from the audience? I believe Parikshit has another question, so I'm just going to... You've been unmuted, Parikshit, so you can actually ask your question through the line.
Yeah, thank you very much for answering that. I was trying to Google what was coming up for our own benefit, but I really appreciate your presentation. You covered a lot of detail, and it's really good. Thank you very much.
My pleasure.
Is there any other questions from attendees on the webinar?
I hope this wasn't... Yeah, go ahead.
Oh, sorry, am I still unmuted?
Yes, you are.
Oh, okay, cool. One of the questions I did have about one of the slides, let me navigate to that one. It was the chart where you had risk versus cost. Let me navigate to that on the PDF. Slide number 19, where you had the prediction slide.
Yes.
So one of the things I noted, the blue lines, the replacement costs and the O&M costs, typically for electric utility, the longer an asset is in service, our replacement costs and O&M costs especially actually begin to increase almost dramatically, like a logarithmic scale. Is there a way to? Well, I love that slide that you have there. Is there a way to kind of, you know, revise the slide, or maybe kind of come up with, you know, some talking points about how your costs end up increasing, you know, and versus your total cost of the asset increases dramatically more. Yeah. You know, as time goes up with O&M. Yeah.
Yeah, so you're absolutely right. I mean, obviously the diagram that I had there is completely generic, and the real thing should be fed by real data. And actually, it will typically be different for every single asset type, or even every asset, based on its real life. So the diagram here was just used for illustrative purposes, but of course you will find indeed either, you know, I should say a palette of diagrams per asset type, or in many organizations you actually don't use a diagram at all. It's actually an algorithm or a kind of little macro which actually does the computation in the background and actually tells you, well, for this particular asset, what I'm telling you, trust me, is you have to replace it in 2026 because I did the math for you. So in a way, the diagram is just there to reinforce what the math tells you.
Okay, thank you.
But you're quite right. I mean, the diagram, I mean, obviously this was a generic one, but you're right. I mean, O&M can get out of control on older assets quite dramatically. It's true on mechanical assets too, if everything starts wearing out. And that might actually drive a replacement just as much as risk does, which is a good point, actually. That is that, you really are looking at the total cost. Or even if you want to push the envelope a little bit further, really cost is only one element. It's really the value that you're extracting out of the asset. So you could argue that cost in that regard is just negative value. So you can also start kind of adding into the same diagram, what are the value elements that I'm trying to extract, and if the value is starting to drop, stuff like if you're trying to, for instance, control noise, if that's one of the elements that you're trying to measure, and if an asset is becoming noisier and noisier over time, you might consider that the value of noise reduction is kind of reducing over time, and that might be part of the exercise too. So you can make this very simple diagram as complex as you want, depending on how many metrics you're trying to track in parallel effectively through the life of the asset to come up with a point of either lowest cost or even better, maximum value.
Yeah, thank you.
Is there any other questions from the audience? As a reminder, you can provide your questions through the webinar interface, or you can raise your hand. No? Well, I guess any final comments from you, Baudouin?
No, I hope this wasn't too overwhelming, especially for us in the West Coast here. It was early morning. It's a bit tough to stomach all that at 8 in the morning. But if there is further questions, please don't hesitate. You have my email address on the screen there, or you can contact Leonor. Quite happy to continue the discussion offline at a later stage.
Good. Well, once again, thank you to Baudouin and Copperly for presenting today, and then thank you to everyone else for attending. For your information, this webinar has been recorded, and a link to download the recorded webinar and attendance list will also be made available to everyone shortly. So in the meantime, if you have any questions, please don't hesitate to reach out to us. Again, thank you all, and I wish you a great rest of your day.
Thank you very much.